Welcome to the week 4 of our calculus course. This week we will learn chain rule. This is a rule for differentiation of composition functions. So today we'll review what composition functions are and how to decompose function when we need to do it. Function is called a composition function if its input is another function and not just a variable x. So for example, if we have x as an input for the function g, then as an output we'll get a function g of x. If we'll use g of x as an input for the function f, the output of the function f is written as a composition function f of g of x. For example, let's say function g of x is equal to x squared plus 16, and function f of x is square root of x. Let's find f of g of 3. The input for the function g is x, and its output is calculated by taking an input, squaring it, and then adding 16. Therefore, g of 3 is equal to 3 squared plus 16, or it's equal to 25. To calculate f of g of 3, we will replace g of 3 with the value 25. So f of 25 is calculated by replacing an input x with 25. Therefore, we will get square root of 25, which is exactly 5. Now let's calculate the formula for f of g of x. Since f of input x is equal to square root of x, and g of x is given as x squared plus 16, if as an input for the function f of x we will use g of x, then instead of x, we will be plugging in x squared plus 16. Therefore, we will be calculating square root of an expression x squared plus 16. This is f of g of x. For the chain rule, we will need to be able to take a composition function and deconstruct it into two functions f and g. Typical exercise for us when deconstructing would be trying to express a given function, let's say h of x, as a composition of two functions, f of x and g of x, such as f of g of x is equal to the original function h of x. Let's figure out how to write function h of x equals to 3x squared plus 7 raised to the power of 5 as a composition function f of g of x. Let's start with the outer function. We notice that we have expression 3x squared plus 7 raised to the power of 5. What if anything raised to the power of 5 will be called the function f? Right now, I have written f as a function that depends on input g, where g is replacing expression 3x squared plus 7. In other words, function g of x is equal to 3x squared plus 7. That's the innermost function. Our outer function f of x is written as an input raised to the power of 5. Since I have written f as a function of x, the input x should be raised to the power of 5. Let's work on part b. Let's say h of x is equal to 4 divided by 5x minus 1. We can view function h of x as a composition function f of g of x. Let's say function f is equal to a quotient 4 divided by, and everything that's in denominator I'll replace with letter g. So if g is our input, f of g is going to be calculated by taking 4 and dividing it by that input. But the letter g replaced a function 5x minus 1. So clearly, g of x is going to be 5x minus 1. So the function f of x will be calculated by taking 4 and dividing it by the input x. One more example. Let's consider function h of x equals to natural logarithm of x cubed plus 2. Let's write this function as a composition function f of g of x. Function f of g calculates output by calculating natural logarithm of input g. Our input g, however, is replaced in expression x cubed plus 2. Clearly, g is a function of x. Writing out f of x as the natural logarithm of x, we complete the exercise. So, natural logarithm of x cubed plus 2 can be written as a composition function f of g of x, where g of x is x cubed plus 2 and f of x is equal to natural logarithm of x. I hope this practice will be very useful for you while you're preparing for the new differentiation rule called chain rule. Until next time.